how we design a regenerative building. I think it's an interesting question. Many people are skeptical about building a regenerative building. Many say it is a greenwashing and it is not possible to do. I think it is valid opinion. If I was back to 2007 or 2008, when I first started explaining about LEED certification, I had one of the professor in a university where I made the presentation gave a comment about the greenest building in the world. He said the greenest building in the world is by not building anything. I think it's an interesting opinion. Unfortunately, that's not the reality. If you see in 2050, we will increase our population 1.6 billion more people. If we put in the context of Colombia, in 2050, you will need one more Bogota. That it means you need more building, you need more space for people to live, work, and have activities. It means we need a more sustainable building in order to reduce the impact to the environment. So what is a regenerative building itself? How we design a regenerative building? I think it's an interesting question. Many people are skeptical about building a regenerative building. Many say it is a greenwashing and it is not possible to do. I think it is valid opinion. If I was back to 2007 or 2008, when I first started explaining about LEED certification, I had one of the professor in a university where I made the presentation gave a comment about the greenest building in the world. He said the greenest building in the world is by not building anything. I think it's an interesting opinion. Unfortunately, that's not the reality. If you see in 2050, we will increase our population 1.6 billion more people. If we put in the context of Colombia, in 2050, you will need one more Bogota. That it means you need more building, you need more space for people to live, work, and have activities. It means we need a more sustainable building in order to reduce the impact to the environment. So what is a regenerative building itself? Regenerative design defined by many people in different way, but as a simple way, you can see the example of definition in the slide. This is an example of definition that I take from Wikipedia, but as a general, you can see the main component of regenerative design. Other definition may be slightly different, but in my opinion, all of them will have or embodied this component. Component of regenerative design is mimic natural ecosystem, more usable form, reversing the negative impact, resilience and equitable system in terms of like how resilient to respond to the natural disaster, and also make the environment more equitable to all the society, the needs of society. So it must match with the need of the society, of the people, of the city, of the community, the integrity of the nature. So try to blend or to mimic or to make sure it is. If you see a regenerative building as a progress of our evolution in a green building, we can see the regenerative design is a process from conventional building, green building, positive impact building, and regenerative design building. In US, we usually consider conventional building is before green for 2010. Before that, it's mostly conventional building. The race of green building happened during 2010 and 2030, which is now. We can see a lot of people pursuing the green building. 2030 to 2050, there will be a lot of positive impact building. It means that the building that actually pushing the boundary more than it is need and have a positive impact to the environment. And the next evolution after 2050, that's a regenerative building. So you can see the progress of timeline from a conventional building to a regenerative building. Yes, it is a future, but you can see here we almost close to positive impact building. By implementing the regenerative design approach, you can achieve the positive impact building much easier. To achieve the positive impact building, we need a new set of a design principle. By using a new design principle, you can achieve higher performance building, greener building, and hopefully you can achieve a regenerative building. I will explain to you one by one later to achieve, but the 5 design principles are ecosystem-centric design, social well-being design, prosperity-oriented design, circular economy design, and disassembly-driven design. These 5 principles will help you during the design process, and it can craft or to enhance your design process to achieve a better goal. Let's start with ecosystem-centric. Let's discuss the first principle. The first principle is ecosystem-centric design. What is ecosystem-centric design? Ecosystem-centric design is a design approach that considers a building as a part of the big ecosystem. By considering that the building will have a positive impact and not negative impact to the environment. An example approach of this ecosystem-centered design is a building that I work with an architect from United Kingdom. Her name is Debbie. She did an amazing project by mimicking the shape of Great Reef to her building. So we're looking at the building and we try to give a positive impact or to approach it as a regenerative building. We take a look our usage of the electricity, water, and the type of material that we use. In the electricity side, we try to reduce the usage of the energy usage and to use the photovoltaics to offset and even to contribute the electricity to the community. So we put more solar panel that we need. In the water approach, we use a reclaimed water, recycled water, as well as collecting the condensation. We also explore the new technology that can change the humidity inside the air and make it into the fresh water. In the material side, we take a look at the material that have low embodied carbon, especially the wood type of material that we can use in the building. I think mostly our approach is to use the wood shape or the wood type of material inside of the building. Another great example is from architect called Kanye. He's from Malaysia. So usually as an architect, we only consider our meshing positioning, sun orientation, wind movement in our design. But he take a look even further to use ecosystem-centered design as a part of his design philosophy. He used what he called as biodiversity metrics. So he looked at the type of birds, type of plant that available in the site, and he take a look how he can or the building can contribute positively to the overall ecosystem. I think that's a very bright approach that we can implement directly in your building. Maybe it's a pretty unique, and maybe starting to change your design process to looking more the ecosystem definitely will enhance the performance of your building. So after we discuss about ecosystem-centric design, we move to social well-being design. What is a social well-being design principle? We try to take a look human as a social well-being. Often during a design, we take a look human as individual person. We take a look the comfort of them inside the building, the direct impact, how to make human being more productive. But we often overlook their relationship with another human being and their social interaction between one human to another human. So in a social well-being design, we try to put the building to enhance the connection between one human to another. How we implement social well-being design into the project. To understand the implementation, you can refer to several guidelines. One of them is a social impact across built environment that was written by World Green Building Council. In that reference, you can see the social impact in the building is divided into 4 scope categories. The first scope is within the organization, or dimension as entity and internal practice. The second scope is a building user and site. The scope number 2 is community and surrounding. The scope number 3 is supply and value chains. And you can see in the slide how they divide each of the scope in the implementation of a social impact in the building. In all the scope, they recommend to consider diversity and inclusion, health, comfort and safety, privacy and security, as well as the climate impacts. The guideline also talk about the implementation across the life cycle of the building, from the design, construction, operational, and manufacturing, and at the end of the life. So this guideline can give you a first step to implement the social well-being design. Another standard that you can use is called SEED. SEED is Social, Economic, Environmental Design. They also have a certification similar to LEED. It's basically a standard to evaluate and certify social, economic, and environmental impact in a design project or in a building. They focus on include the community voice and address a social equity in a project. The implementation of SEED include advocating for those who have a limited public voice, building inclusive structure, promoting social equity, generating locals grown idea, and conserving resources. Using those 2 standards, I think you can start considering approach that you can use in social well-being design in your project. So I think you can assess both standard and take a look which one the component that you can start implementing. I think that as a starting point, I always say you don't need to adopt everything, but take a look the value that you can take from those both standard that you can use to influence your project become the better building. Using those two standards, I think you can start considering approach that you can use in social well-being design in your project. So I think you can assess both. After we discussing about social well-being design, we move to the third principle of regenerative design. The third principle is prosperity-oriented design. The goal of the prosperity-oriented design is to improve the economy of the people who use the building and its surrounding, or even in a bigger context like a community or city. After we discussing about social well-being design, we move to the third project example in prosperity-oriented design. It's a Brooklyn Navy Yard. It was a Navy Yard complex. However, it is currently a light manufacturing facility complex. The goal of the manufacturing facility complex is to provide employment or job to the surrounding community. The government subsidizes the renting so they can keep manufacturing works inside the city. So this is actually a very good example of prosperity-oriented design. I was fortunate to work in this project to decarbonize the complex and to do electrification planning. So the project not only another example of prosperity-oriented design, it's a hospital in Shanghai, China. The hospital was designed to be a pilot green hospital in China and the first sustainable hospital in China. If you look at solely at the impact of the environment, maybe you can consider the building has negative impact to the environment. The existing site actually a paddy field, and they rebuild it and put the hospital that can serve the community and provide a better and healthier community and easier access to the community to the health center. Another example of prosperity-oriented design, the hospital become the center of healthcare in the city, and as the result, the hospital will increase the prosperity of the community and the city. After we discuss three principles in regenerative design, we move to the fourth principle of regenerative design. The fourth principle is circular economy design. What is a circular economy design? Circular economy design is an approach in design to minimize waste and to make use the most of the resources of product, building, and materials. Unlike traditional linear approach that using approach like take, make, and dispose, circular economy design try to keep building as long as possible through the strategy like leasing, reusing, refurbishing, renovating, and recycling some of the component material in the building. To implement circular economy design, we use a life cycle assessment. Life cycle assessment is different with the life cycle cost. Life cycle costs focus only in the economy. Life cycle assessment usually focus more in environmental impact. In the life cycle assessment is usually divided into 4 stage category. The 4 categories in life cycle assessment are product, construction, maintenance and use, end of life, and beyond the life cycle. The product starts from extraction of raw material through the manufacturer of the product. Construction discuss about the process of the construction. Maintain and use discuss from the usage, repair, replacement, energy usage, and water usage. The end of life discuss about demolition through the disposal of building or material. The last category, beyond life cycle, is looking more detailed component in the material or product. For example, the recycled value of the steel, the sequestered carbon in the wood. So the life cycle assessment looking the implementation of the building through the lens of carbon. Is it enough to look at the building through carbon factor only or environmental factor only? I think we need to assess the building through more holistic approach or multi-factor assessment. This is an important assessment process that should be implemented in regenerative design. To see the use of multi-factor to assess a decision, this is a simple example that I generate through AI in Copilot. I make a comparison between the use of private jet and the use of plastic straw. I think it is an interesting thing how the AI can generate the answer in this question. Through back and forth with AI in Copilot, the AI was able to generate a really interesting assessment using a multi-factor. In here, they were able to compare the use of the private jet versus the plastic straw. I also mentioned carbon offset will be implemented in the use of private jet. And in the plastic straw, I mentioned there will be 100 plastic straw used in this comparison. You can see there are many factors that consider in here. I also requested to them to give a value or quantitative assessment or comparison that I can use to make a decision. The answer might not be correct, but it is a practical example that we can use in a building as well. In building, we should consider multi-factor not only through the carbon lens only. Using this multi-factor assessment, you can generate a better building and achieve the regenerative building. Definitely you need to make a discussion with your project team and client what factors that you should include in your multi-factor assessment. Some people also mention about benefit cost assessment. Those things should be considered as a part of the key tool to achieve regenerative building. Through back and forth with AI, after we discuss 4 principles in regenerative design, we arrive to the final principle in regenerative design. The principle is disassembly-driven design. Let's take a look what is disassembly-driven design. Disassembly-driven design is an approach in architecture to take a look how the building will be designed and how should we do in the end of the life of the building. Typically, people look at the end of the life of building as demolition. In disassembly-driven design, we want to disassemble the building so we can recycle, reuse, and repurpose the material of the building. Is disassembly-driven design possible? A corporation called Taisei Corporation in Japan implemented disassembly-driven design in a building. Instead of demolition, They use a disassembly method to reduce the air pollution, noise, and carbon to the environment. They said this approach will reduce 85% carbon to the environment. This approach should be used in any building in the world. We shouldn't do a demolition. Instead of that, we should disassemble the building. By disassemble the building, we can repurpose of the material, reuse or recycle the material in the building. In recent project in Los Angeles Airport, they use a design approach that can enhance disassembly-driven design. They design a building that can be constructed off-site, and after that they bring the building, once it's ready, module by module, and connect it on-site, so they can build a connection of the terminal easier and faster. This technique will result the building will be easier to be disassembled. So when you design in the future, please consider to think how the building will be disassembled in the end of the life. It is very important to reuse, repurpose, and recycling the materials in the building, or even to extend the life of the building through this technique. So we hear all the principles in regenerative design. Now I challenge you to think and use one of them in your next project. I believe your next project will be performed better, and hopefully step by step you will achieve a regenerative design in your project in the future. Let's achieve a greener future, and feel free to contact me if you have any further question, and I look forward for more discussion with you.